Okay, here we are, the last of the inquiry sessions for this inquiry about how many bulbs is too many. And today we're looking at splendid switches. The walk for this session is to explain how a switch works and why they are needed. So here's three examples of things that go in circuits. There's a bulb, there's a buzzer, and there's a motor. I'd like you to think about circuits around your house that would use a bulb, or a buzzer, or a motor. And hopefully you came up with the lights in your house, a front doorbell, and then something that has a motor, such as, in their example, a drill or a washing machine. Now, if we put those things into complete circuits, there's a few problems that we need to think about. First of all, do we want the doorbell ringing constantly? Do we want the lights on all the time? Why would it be a problem for a drill to be running all of the time? What are the practical problems of having complete circuits in everyday life? And what is the solution? Now remember, an incomplete circuit will not work at all. And the solution is switches. We need to introduce a switch into our complete circuit so that we can break the circuit when we need to. So here are a variety of switches that can be used. See if you can match the type of switch and its name. And pause the video at this point while you have a think. So that's a slide switch. Now normally you'd find them around the house in toys, games, radios, somewhere where it needs a small switch that can be easily slid. Paddle switch. That should be a fairly easy one to spot because nearly every light in your house will be turned on using a paddle switch. Push button switches. They're a little bit harder. Have a think about how you turn on your mobile phone or your tablet if you've got one. What sort of switch are you pressing? Selector switch. They're a bit harder to think about where they fit in a house. I know in our house we have an extractor fan over our cooker which has many speeds, and that uses a selector switch to change the speed. Pull switches tend to be found mostly in bathrooms, places where you might have a wet hand but still need to be able to turn things on and off. Key switches. Now you might have an alarm system in your house which uses a key switch, but when I thought about this one, my immediate idea was it's actually used outside the house. When I get into my car, before I can start the engine, I have to put a key in and turn it, and that switch starts the engine. Dimmer switches are used on lighting circuits. And finally, toggle switches. Again, that's the sort of thing you might find on a toy or on a piece of electrical equipment that might be used outside the house. Move on to how switches work. Now, a switch breaks a complete circuit on purpose to stop the flow of electrons when it is off. When the switch is on, the circuit is complete again, and so the electrons are able to flow around the circuit. So remember, a circuit with a switch is not the same as an incomplete circuit. In an incomplete circuit, the electrons are unable to flow at all, whether the switch is on or off. So if you look at those two illustrations they've given you, they're not complete circuits because the wires aren't going back to the battery. And so as a result, no matter what you do with the switch, it's not going to make any difference to the light bulb. To finish with, I'd like you to go around your home. How many different types of switch can you find? which type is used most in your home. Don't forget to look outside as well. When you've finished, you could try drawing a bar chart to display your results. The document you need can be downloaded from the class learning page, and it's also got a sheet of squared paper so that you can draw that bar chart. And if you can take a picture of your bar chart, post it on the Padlet so that we can all see it. I'm hoping that you can now explain how a switch works and why we need them in our electrical circuits.